Hey everyone, I'm Cameron from Prohelion. This is my colleague Sam.
Hi guys.
We're basically going to take you through some of the common issues that we find that people have when they're first setting up this equipment and just explain some of the solutions and why things work the way they do. So yeah. Sam, I thought we might start with a really common one, which is precharge. Do you want to take us through what precharge is all about?
Yeah, sure. So on these high-powered or even small capacity battery systems, the batteries themselves have a really low impedance in terms of being a source, and they can discharge a lot of current very quickly. When you go to connect, typically in a system like this, when you go to connect a battery to an inverter, most inverters will have a large DC capacitor bank that is used for filtering and stabilizing input DC for the motor controller itself. That can cause, or will cause, a very large inrush of current. So when you're connecting a battery to a wider system, it's really important that you do something called precharging. Precharging sounds complicated, but it's pretty simple. All you're trying to do is lower the inrush current to an acceptable level for your system.
So we're basically trying to balance the voltages effectively up. Is that what's happening here? Or
yeah. So you can consider any capacitance on the wider system being at 0 volts when you go to turn the battery on.
Yeah, okay.
And you're trying to bring that voltage up to the same voltage as the battery in a controlled manner.
Yeah, so nice slow, bring it up, and then we've got the ability to engage the pack at that point because things are more balanced effectively on each side. Yeah, okay.
So I've got here an example of a contactor high voltage distribution block that's in this system here. Just to quickly run over it, we've got the two main contactors that control the positive and the negative output of the pack. And we've also got on the side here the precharge relay. So this relay, when controlled by the BMU within the battery, will switch the internal high voltage to the output high voltage positive through a power resistor.
That's the only reason that resistor's there is just basically for this precharge function.
Exactly. Yeah. So this precharge resistor just acts as a limiter for the inrush current and allows the voltage on the output capacitance to come up in a controlled manner.
Yeah. So when you're designing a battery pack that's using one of our BMUs, I mean, we produce these sort of boards, but a lot of the time our customers are actually producing this component of the system themselves, designing that for spec, and there is recommendations in the documentation on the sorts of resistors to use and the process that you need to go through to make precharging work safely and well, because it is a really important process to make sure you're not damaging equipment on the other side of these contactors.
Exactly right. So in the Prohelion manual for our BMS, there's a whole chapter there on selecting the correct size precharge resistor for your system, and it takes into account your system voltage, so that your battery voltage, and your bus capacitance. So your bus capacitance usually is indicated on your motor controller datasheet. If the OEM of the motor controller doesn't specify the bus capacitance, sometimes that can indicate that it handles its own precharge. But I wouldn't make that assumption because you can kind of get a bit unstuck there.
Risky assumption to make, right? If you get it wrong, you're potentially going to end up with damage. What happens if you're not dealing with a motor controller on the other side of the contactors? What's the right approach then?
Our recommendation is just to always have precharge. Even if you're dealing with a load that's purely resistive. So if you're powering a big a resistor heater or something like that, the only thing that's going to happen then is precharge is going to happen instantaneously because there's no capacitor to charge, and the system's going to operate as normal. So there's really not a negative to including precharge in a high voltage battery system, which is why we always recommend that it's there.
And so what are the steps that are going on in that precharge process? When when you say to the BMU engage, what's actually going to happen then? What's the BMU going to do?
So the first thing that the BMU is going to do is it's going to engage the negative contactor, and then the next stage is to engage the precharge contactor. At that point, it starts measuring the voltage of the output while simultaneously measuring the battery voltage. And then once that output voltage rises to be at the same level as the battery voltage or within a set threshold that you can configure within the BMU, it will engage the main positive contactor.
At which point the current flows normally.
Exactly. So you're just trying to limit that inrush current, which can either damage the connected equipment or it can damage your contactor. Because you can weld the contactors if you don't have precharge. And that is typically the failure case that you'll see without precharge.
Which can be quite a dangerous scenario. So it's definitely worth doing. All of the settings that Sam's just talked about, those are configured through Profinity, and they are configurable to set the different ranges and the time periods that things are going to occur over and so on. So, if you wanted to change anything, we do have some recommended values in there, but if you wanted to change anything, that is possible. With all of these things, if you've got any questions about this sort of stuff, it's worth reaching out to us. We have a support system. You can go to our website, contact us, go to the support portal, lodge a support query. We're always happy to help out where we can. And just this is one of these things that's really important to get right.
Yep, absolutely.
And so if you've got any questions, by all means, reach out to us. We'd be more than happy to help you. Anything else?
No.
On Precharge?
Yeah, I think just following what's inside of the BMS manual and making sure that you spec your precharge resistor so that it can handle the amount of current that it's needing to precharge with, and also that the contactors that you are using are rated for the voltage and current.
And go from there. Fantastic. Thanks again. Hope you found that useful, and good luck with building a battery.